Good morning everyone, and welcome to today's worked exam answer video. Today I am having a look at an inorganic chemistry question from the year 12 part of the AQA A-level specification, having a look at group 2 elements in terms of solubility of the hydroxides and the sulfates, and then linking that into the chemical test that we can perform to identify a sulfate ion being present in a solution. So this is a 6-mark question, and again it's a slightly older question, and I know that because we're still spelling sulfate with a PH, which has not been the case for a while now. We now spell sulfate, sulfuric acid, sulfur with an F, and yes, we did used to spell it with a PH. That was the English way. Anyway, but it doesn't matter that it's an older question. All of the content is still relevant to what you might get asked today on either an AS or an A-level AQA paper. So we have been asked to state the trends in the solubility of the hydroxides and the sulfates of the group 2 elements magnesium to barium, and that's very common that you will only be thinking about what is 4 elements, so magnesium, calcium, strontium and barium. There is beryllium above magnesium. I don't think I've seen a question ask you about beryllium at all really in relation to this sort of thing. And below barium we have radium, but again in relation to this they've never asked. So those are the main 4 that you'll be thinking about when we think about group 2 elements in relation to hydroxide, sulfates, chemical tests, all of that sort of thing. So we've got to state the trends, and there's 2 trends, so 2 trends, hopefully 2 marks. Then it says describe a chemical test that you could perform to distinguish between separate aqueous solutions of sodium sulfate and sodium nitrate. So we're going to need to use our knowledge of the trends in solubility of either the, of the sulfates, because we have a sulfate as one of our 2 compounds, and then know how to test for the presence of that particular sulfate. So state the observation you would make with each solution, and then write an equation for any reaction that occurs. Okay, so even again, although it's 6 marks, it's an inorganic question, so there's a bit of recall here again that we're going to need, and the question is fairly nicely broken down into kind of different things you need to address, and so we can look at that and go, okay, 2 for the trends, outlining the chemical test, we've got observations, we've got an equation. Perfect. So the trends with the hydroxides and the sulfates are inverse to each other. So the hydroxides get, I'm trying to think the best way of doing this, I'll do my arrow going down the group. The hydroxides get more soluble as you go down group 2. So magnesium hydroxide is the least soluble of them all, whereas barium hydroxide is very soluble indeed. And then the sulfate trend is the other way around. So as we go down the group with the sulfates, they then get less soluble. So the magnesium sulfate would be the most soluble, and barium sulfate would be the least soluble. So I'll put those into sentences to start. So the group 2 hydroxides become more soluble from Mg to Ba, so magnesium to barium, whereas the group 2 sulfates become less soluble from Mg to Ba. So when we're then thinking about our 2 solutions, we've got sodium sulfate and sodium nitrate. if the sulfates get less soluble as you go down the group, barium sulfate would therefore give us a precipitate, whereas if I were to add something containing barium and I made barium nitrate, all nitrate salts are soluble. So forming an insoluble sulfate is the way in which we're going to be able to distinguish between our separate solutions of sodium sulfate and sodium nitrate. So the, I guess, standard chemical that we add is barium chloride, but it doesn't have to be barium chloride. There are other non-metal ions we can use, like barium nitrate. The key thing is the barium-based compound that we use needs to itself be a solution, or, you know, dissolve to make a solution, and also we don't want to include a negative ion that might then react with the sodium in this case to then give us a precipitate in any way like that. And all kind of examples that I've ever done, I've always used barium chloride, because the majority of chloride salts are soluble. I know all nitrate salts are, but I've learnt it to be barium chloride that we would add here. So that's what I'm going to say. Now, we should add acidified barium chloride in case there are any impurities within either sample. So if we were to have some carbonate ions in there or some hydroxide ions in there as an impurity, then the acid that we add alongside the barium chloride, which would need to be either nitric acid or hydrochloric acid, that would react with the impurities so that they don't then form precipitates with the barium, because barium carbonate would be a precipitate, barium hydroxide wouldn't be, but barium carbonate would be. So that would then give us an additional observation that is going to be like a false positive observation. So yeah, I'm going to add acidified barium chloride, and then I'll specify that I'm going to be using either HNO3 or HCl for my acid. Can't use sulfuric acid because that's then going to be adding sulfate ions into the mixture, and then again we're going to get that false white precipitate, certainly with the sodium nitrate. So we're going to add acidified barium chloride, and then observation wise, with sodium sulfate, which is Na2SO4, we would get the barium and the sodium doing like a double displacement, so we'd end up forming sodium chloride and barium sulfate, and the barium sulfate, because the solubility decreases as you go down the group, will be a precipitate, and we need to know that barium sulfate is a white precipitate. So that's what we would observe, white precipitate of barium sulfate. With sodium nitrate, NaNO3, we're going to get the same double displacement, so we're going to make barium nitrate, all nitrates are soluble, sodium chloride is soluble because all sodium salts are soluble, so we're not going to see any visible change because we've got colourless solutions which will then be making other colourless solutions, so no visible change or no observable change. There is something happening, so don't say nothing or no reaction, because there will be a reaction, it's just we're not going to be observing that. Now interestingly, it says write an equation for any reaction which occurs, so we are getting reactions in both, so I am going to have to do an equation for both, but the fundamental one is with the sodium sulfate. And if you had have used, for example, barium nitrate instead of barium chloride, you wouldn't have got any reaction with NaNO3 because you'd have NO3 as both of your negative ions there. You'd only have to write one equation. However, we're going to need to write two because there are two reactions occurring, even if we can only see what's going on in one of them. So starting with the Na2SO4, that will react with the barium chloride as I described in a double displacement reaction to give us the BaSO4, which is my white precipitate, and then we're going to get sodium chloride. And as always, with any chemical equation, we need to balance it. So I've got 2 sodiums and 2 chlorines, so I'm going to make 2 NaCl, and then I'm just going to put some state symbols in there. So it says in the question that we've got separate aqueous solutions. So the sodium sulfate will be a solution. We would be adding the barium chloride as a solution. Barium sulfate would be our precipitate, so solid, and then sodium chloride will dissolve to give us an aqueous solution. My equation to finish with my sodium nitrate, which was also a solution, reacting that with barium chloride would give me barium nitrate, and I'm going to need brackets in my formula for barium nitrate because barium plus 2 charge, nitrate ions -1. If I need 2 nitrates, I need the brackets to show I want 2 of everything in the brackets, so a total of 2 nitrogens and 6 oxygens. And the other product will be sodium chloride. These would both be aqueous, and the barium chloride that we added at the beginning, also aqueous. And then balancing wise, if I've got 2 nitrates in my barium nitrate formula, I'm going to need a 2 in front of my NaNO3, and then I've got a 2 in front of my Na now, and I've also got my 2 chlorines from here, so 2 lots of NaCl again. Okay, so that is everything that we need to do there. These trends need to be learned so that you can regurgitate them. We need to know how to test for sulfate ions by adding something containing barium as a solution so that we make barium sulfate, because that is the least soluble sulfate. And then we've got some equation skills at the end there. Anything that I've said today is not clear and you'd like me to clarify, you've got questions, please do not hesitate to reach out and ask me in whatever medium works best for you. Thank you so much for watching, guys, and for all of your support over the last week. It's been really much appreciated, and I hope you all have a very good day. Thank you. Bye.